Now here's a case where it really helps to know the exponent rules. And remember, the main thing is that for any radical, we can turn that into an exponent that involves a fraction. So I'm going to zoom in really close here. All right, there we go. So let's just go by piece here. So this top part, remember, is a squared, and we don't write the 2, but it's there if we need it. And we do need it in this case because I want to convert that to x to the 5 halves, right? The 5 over 2. So the 5 that's in the, or is already on the x, that's going to stay as a regular old exponent, except now it's the numerator, and the denominator of the fraction is whatever was in the root. So we can do that to the bottom as well. That's going to be x to the 4/3. So right away, now we're out of radicals, and that's where we want to be. Radicals, annoying to think about all the time. Now we can try to use our GermDAS strategy here to remember what to do when we have different kinds of things. So if we have, and we kind of just did it, right? We had radicals, and what do? We kind of divided the two pieces. So that kind of works there. But even more so, now we have division of two things with the same base. So we move 2 spaces, and that gives us subtraction. So we're going to subtract these exponents. So what we're really doing here is x to the 5 halves minus 4/3. And we want to see that being equal to x to the a over b. So I don't care about a and b separately. I only care about the whole thing. At this point, you can do the normal stuff with fractions, but I'm going to be lazy here. Let's just throw it in Desmos. So 5 halves, I'm just going to come out of it, minus 4/3 gives me a messy decimal, and I could enter that if I really wanted to, right? But I'm going to turn it into a fraction by hitting that button, 7/6, and now I'll enter that. Because I don't like repeating decimals in these student-produced responses. I would much rather enter it as a fraction, so I don't have to worry about the rounding and all the spaces and all that crap. So it's just better to think of it as a fraction if you can. But yeah, there you go. This is not hard. We could arithmetize here if we really wanted to. You would just need to pick a number for x and then basically work your way to the end. The only problem I can foresee is you still at some point need to kind of figure out what this exponent would be. I think it's going to require a little bit of guess and check. If I'm wrong there, feel free, put it in the comments. Is there some way to arithmetize here that doesn't involve a little guess and check or kind of doing some weird radicals to solve for that? I think it's going to be like a logarithm question even. So this is why with exponent rules, we're always just better off knowing the rules themselves, but sometimes we can get away with it by doing a little strategic approach if needed.